So hi again for everyone. Thank you very much for joining. In this following session, I'm going to talk about distributed microservices and how to trace and gain observability to such cloud environments. My name is Ran, and you can follow me on Twitter at any time. I'm going to give some more details. Just before that, if you're interested in asking any questions, you can do so through slido.com. Just put DevOps 2020 and get into hall one. Once you get into hall one, you'll see that thing over here, and just feel free to ask questions. I'll go to the questions at the end of my session to answer all of your questions. Thank you. So let's get started. Perfect. So first thing, nice to meet you all. My name is Ribenzaft. I'm the co-founder and CTO at Epsagon. I'm also an AWS serverless hero, which means that I'm very much involved in the serverless community. And over here at another picture of me, you can see me looking for wells in Hawaii. Unfortunately, I couldn't make it to find any one of them, but that's another deal. And you can follow me on Twitter. I usually talk a lot about tracing and observability and the monitoring space and cloud. So you're more than welcome to have a peek over there. Just a few notes. I'm working at Epsagon. Some of the things that I'm going to speak about in this session are part of the things that I'm working at Epsagon. We're at Epsagon doing automated and agentless observability and tracing. That's for the self-shaming. And now I'm going to move towards what we're here for today. So when we're thinking about complex applications, and tracing specifically, we have some evolution throughout the years. I think I would love to cover a bit about the past, about monitoring and logging and the way we used to do that, and then to talk about the broader spectrum that's called observability, and then dive exactly into what's distributed tracing, how it works, and how every one of you in the crowd can leverage that. So let's get started. I think that the most simple question that we need to answer first is, why are we monitoring? And some people would say to make sure that we, our timings are right and no downtime and things like that. But I think the most obvious answer is to make sure our business works, okay? If our business is not working properly, it doesn't matter which application or what technology we got behind the scenes, we just can't move anywhere. And in terms of monitoring, so there are a few things that we can look at when we want to make sure our business is working properly. And a very good recommendation, especially for such days where everybody is in their homes, is to review the SRE book from Google that includes the 4 golden signals for modern applications, for microservices and distributed applications. And it defines 4 crucial signals to look at. So the first one is latency, and it's pretty obvious. Your application is interfacing with customers, and customers want something as quickly as possible. Now, that really depends on what kind of application you're having, but latency, how long it takes for a request to be processed on your end and then reply to your customer, that's the latency that you should measure, and hopefully you should do it as fast as possible, and you should also define your limits. Second is about the traffic. Looking at how much traffic you're getting, it's also a vital sign of your application. If you're getting more and more traffic, it means that you need to be aware of it and do something. Also errors, which is a very obvious one, because if you have no errors, everything is perfect. But if you're having errors, you need to understand them. You need to understand whether it's trends or a specific error and what's actually going on. And then saturation. Saturation, in other words, says how full is the service or the server that I'm interacting with. Because, for example, the traffic can grow very steadily and everything looks fine and the latency stays the same. But all of a sudden, if your saturation reach 100%, it means that you can't handle any more requests anymore. So we're just going to stop working. So that's something that you need to look at as well. In the old school kind of monitoring, when we had a server that was in some sort of a REST API or even a web application, we used to have all the business logic in the same server, and we had a database that we were talking into. And usually to get monitoring into such environments, we would start with deploying some agent on that server. This agent used to collect the host data information. It means that it's only about the host, like processes and network traffic and disk and things like that. It was limited only for this kind of metrics, and it was limited only for metrics. It couldn't ship any payload or information about what happens. It's just about this is the CPU record that I've just snapped out, and this is the disk snapshot, and everything as a metrical data for every timestamp. Now, when we're having a problem, metrics can't help us to solve the problems in most of the cases. We need some more information. We need some more debug data, which is not metrical information. And honestly, what we need is logs. So in order to gain logs, old school kind of logging is to have another agent running on the server where all of the applications were writing into, and this could dump the information locally or remotely. Usually, on the old days, it was locally on the same server, but then we understood that when we're having 10 servers, we're not going to log into each and every one of them to look at the logs. So we were using this kind of agent to ship all of them into a centralized location. And the third part is that it collects only log data. I mean, if I haven't manually logged the information to that agent, it wouldn't collect him for himself. I mean, it's my logging. I'm responsible for it. The agent just captures it for me. Now let's jump into the future a bit to see how things are working now, and what are the best practices. In the future, or in the present, the future of software, we're talking about a more managed application with cloud resources and cloud environments being utilized. We're talking about microservices and containers, and sometimes serverless. We can see that the grow over here for cloud and microservices and serverless is growing fast, and there's a reason for that, because it helps us teams, engineering teams, to innovate faster, to work faster, to ship software faster. So it makes a lot of sense to use it that way. Now, if I'm talking about the shift that we had in our applications from what I showed before to what we got now, so it has two main parameters. And let's start with the first one, which, it was host-based. I was responsible for the host, whether it was a VM on-prem or even VM on cloud, but it was usually a single host that included everything. And it was a monolithic design pattern of application there, where everything was on the same location. Now, over time, we understood that making our application distributed can help us innovate faster, scale only the things that we need to. So we broke down the application into sub-services or microservices, still running on different hosts, but now we can interact with each one of them individually. And the third step is to go also to cloud to abstract the host as much as possible. So containerized environments, I don't really care about which host they're running at. Web servers, message queues, third-party APIs, databases, storages, and everything are starting to become more and more abstracted. So for me, I don't need to handle all this fleet of servers. I'm caring about more the application rather than the infrastructure, which makes sense. Our application is our business. Somebody just, transparenting the whole infrastructure layer for us. And these kind of environments are becoming much more harder to troubleshoot or understand. Specifically, if we're talking about the challenges of engineering and DevOps teams, so the first and foremost problem that we're having today is troubleshooting. When we're having, a user coming into the website and interacts through several services, and all of a sudden he gets some error, now we're the ones that need to do this root cause analysis to understand exactly what happened and what led to the problem and which user was that, and correlate between all the logs. This has just become a painful task that can take hours or days to understand. So it becomes just much harder to do in these days. Second thing is monitoring. When we used to have a single server, some CPU stats, RAM, disk, and so on, it was pretty simple. But now we have so many resources. Each one of them we should treat differently, and each one of them got a different way that I'm looking at. So it's just becoming a mess to have everything under the same dashboard, everything in a unified place that tells me this is your application in a visualized way, and tell me about bottlenecks or issues or pain points in my applications. And I'm also talking about that it should be automatically and not me need to gather and build out these things. Both of these things leads me to the fact that it also affects our development velocity, because the harder that we get to troubleshoot and monitor, the harder that we get to develop, because everything that we're experiencing on production, we experience first on the dev environment. And if we can't do this on dev fast, it's going to impact our production and vice versa. Now, before I'm jumping into distributed tracing, let me talk about the bigger umbrella. We talked about monitoring or metrics, and we talked about logging. But we also got another pillar to complete this picture that's called observability, which is tracing. So metrics are pretty obvious. I'm snapshotting something for a long time, and then I can see and aggregate it to detect trends or anomalies or understand the performance over time. Then I got the logging events that tells me this is exactly what happened that I put into the logs. Now, tracing helps me to glue between these pillars and also helps me to understand what services are interacting with one another. So I'm having a correlation between each and every request in my system. So it's not out of the blue. It's not just random metrics and random logs that I need to correlate in between. Usually today you'll find out a tool for each and every space. For example, tools for metrics, tools for logging, and tools for tracing. But I think that the best case scenario is to have all of them aggregated under the same tool. Now, before jumping into distributed tracing, which is the main part of this session, I want to talk about some best practices both in monitoring and in logging. So let's start first with monitoring. First thing that we're doing with monitoring is, as I mentioned, it almost must have to aggregate all kinds of metrics into the same dashboard. Otherwise, you just can't see everything in the same place, and it would be a nightmare to troubleshoot problems, especially in the middle of the night that you need to understand what happened. Logging into different systems will just consume all of your time, and just it can't scale that way. Also, you should define your critical metrics, especially if we're talking about waking in the middle of the night to solve something. You don't want to wake up for every stupid solution. You want to wake up only when there is a real problem. So make sure to define the right threshold for your problems. It can be a certain amount of errors or a certain duration or latency, and not just every specific error. Also use custom business metrics. I mean, you can ship out some more information about your current application that will tell you much more than the dry kind of metrics. For example, when user buys something in your shopping cart, you can say how many items did he bought, and then it can be really helpful for not only the engineering but for the product or other teams in your company to look at them, because again, we're monitoring for our business sake, and this is part of our business. Also, in terms of monitoring best practices, some examples that you might want to look at in your applications. So first of all, sorry, one step backwards, you should monitor your application metrics. Sometimes people think that, okay, I'm monitoring CPU and memory and disk and network, and that's it, I'm covered because I'm monitoring everything. I've got metrics for all of the things that I've needed, but the application is the most crucial part over here. If the infrastructure is working properly, but the application is not, that's your problem. You need to fix it. So monitoring application is super crucial. And when monitoring application metrics, you can look at some of these examples. For example, what's the average duration of a call to my HTTP API? It can be, by the way, average or percentile. We can talk about percentiles if you're interested in that to understand more. But that tells you how long users wait for interacting with your server. Also, you can monitor the minimum number of calls in a message queue or in a process pipeline, because that tells you how much calls you're having. And if you're having less than 10 calls per day, it means that something not working properly, because you're usually used to having thousands of them every day or millions of them. Now, also another crucial one to look at is the number of 400 and 500 errors. This is very popular with HTTP endpoints, and this tells you how many errors your users are experiencing with their communication to your product or your application. In terms of logging best practices, so I think it's really recommended today to not print out just raw logs, but other than that, to print out JSON data or dict data, for instance. So if you're having a message that you need to print, for example, now I'm doing something with customer X. So instead of just printing that, print that with some more metadata. So one of the fields will be the log itself, but some other fields will be like, which service am I? or what is the stage that I'm at, or even what customer am I handling. Once you're printing it out JSON, you can index it on almost any logging solution out there, and you can first of all easily pinpoint these kind of problems. For example, show me only error logs from service X at stage production, where user was 1 to 3. So it makes it much more easier for you to filter that out. But you can also aggregate data in order to visualize, for example, how many calls does this user have in your website, or how many calls does this specific service gets in production stage. Also automate the process of logging as much as possible, because as I mentioned at the beginning, you're responsible for every log line that is being printed out. If you're not logging information, it's just not going to go out by itself. But there are ways and techniques to automatically consume logs, even from your application, using instrumentation. I'm going to talk about instrumentation later on, but have this in mind that the next time that you're logging, think of, is somebody gonna want to do the same logging that I'm doing? Let's do it in a more automated and infrastructurized way. Also index the field that you're using. That applies for the same element that I've talked before for the printing out JSON data, because that will help you aggregate the information and filter it much quickly in your services. Even when I talked about best practices for monitoring and logging and metrics and so on, there is still something that's missing, something that wouldn't work for modern application, hybrid application, cloud, managed resources, and so on. First issue that comes to mind is, how do I correlate between metrics and logs? Because let's say I'm having a problem, the IT team or somebody called me to fix something, like my database is performing slower than expected. Now I'm the one that's responsible for looking at the logs of the database or some services that are communicating to the database to, sift my way through these logs to find out what's causing this kind of delay. And since these are two different tools, they have no correlation between one another. It's on me to correlate what happened in one tool to the other tool. Also, even if I'm having this kind of correlation, the applications are becoming so complex. It's usually not just a single service or just a single resource. It usually involves, a handful of services or even tens of services in a single flow that the user interacts with your application. So being able to correlate a request between different services is another key component to understand and gaining observability into our modern applications. With that, I think it's a great segue to start talking about distributed tracing, which is the missing key that we've talked about. Distributed tracing, in very short, tells me a story. It tells me a story how a request is going through services in my application. So in one example over here on the right side that you can see, so a client make a request that goes through my load balancer, then goes to my authentication service and comes back, and then to the billing service to charge him and goes back, and then to the resource that it intended to be. This, using distributed tracing, it tells me, okay, 1, 2, 3, 4, between which service and what service. So it really helps me understand exactly what's going on. This kind of correlation that sticks all the services together. And in order to do distributed tracing, there are two parts to accomplish it. The first part is to generate traces, and the second part is to ingest the traces and get it or view them through some client. In order to generate traces, there are two popular frameworks today, both under the CNCF, the Cloud Native Computing landscape. One of them is Open Tracing, and the other one is Open Telemetry. In this conversation, in this talk, we're going to speak about Open Tracing, but throughout the years, Open Tracing and another standard called Open Census merged into Open Telemetry, and now this is a work in progress. The other part for ingestion in the client, we got another CNCF tool, which is Jaeger Tracing, and another cool tool called Zipkin. In this specific talk, I'm going to refer to Open Tracing and Jaeger in my examples. Let's talk about what it takes to generate traces. So first of all, we talked about instrumentation. Now, think of it that way. We're communicating to our Postgres database to do select and queries and update queries and any kind of queries that there are. Now, in my code, every time that I'm calling the database, Postgres database, I don't want to put another line that says, now trace this call. I want it to be automatically to trace every outgoing call, regardless what kind of operation, to my Postgres database. In order to do so, the technique called instrumentation. And instrumentation tells, let's hook into the relevant library or module behind the scenes. So every time that you're making a call to Postgres, it will be like a hook or a detour that goes through this function. Once it's going through this function, you can see the request because it's coming through your end. And you can see the response because also the response is routed through your detour, through your hook. So once you're doing this kind of hook, you can apply once this kind of tracing that tells now record this Postgres operation and extract the method and extract the exact query and extract the status code and the response and everything that you're interested in looking. This instrumentation is applied for every framework and every library that you're using. For example, AWS SDK, HTTP libraries, Postgres, Spring, Flask, Express, and so on. This is, it's a finite list of libraries, but it's almost endless because you need to catch up with all the versions and all the scenarios to instrument. But at least once you did it, that's it. No more engineers or ops people need to work for creating the traces. Once you're in the instrumentation process and you hooked into the right library, so you need to create a span. And now I'm talking about open tracing terms, okay? So I need to create a span. Span is like the basic unit in tracing that tells me about an operation that has some duration, like it has a start time and a duration. So for every request and response that's coming in and out, I need to create a span. This span will include the basic information about, what is the start time, what is the operation, what is the resource, and so on. To that, I need to add also some context because just looking at, update operation that took 300 milliseconds, it's not very meaningful. I need to add some context like which database is it? What is the host? What is the old query maybe? What is the status code? What was in the response data? So I need to add some more context that will help me once I'm troubleshooting or looking at it on the other end. I need to have some more information. Now, in order to actually correlate between different services, let's say I'm having two services that are communicating through HTTP requests, I need to create some correlation ID that will be injected and extracted on each service. So let's say service A is sending an HTTP call to some service. I would like to inject in the headers some correlation ID. This correlation ID can be UUID or any other thing that you're interested in, but something unique enough that will tell the other service, hey, other service, now that you're extracting this message, if somebody else is out there, please note that you're part of another request. And by turn, the service B that accepts the message will extract the header, for example, from the HTTP, and it will look, is there any magic header that I need to look at? And if so, what's the ID? If I'm finding that right of ID, I'm gonna use it and say, I'm gonna create a span, but this span is a child of, or it has a reference to the other span to the other trace that already started. So remember, we need to create a span, add some context, and inject and extract IDs when we're moving between services. Just as an example, this example is in Python and it's in a web framework in order to get some requests. So the instrumentation parts comes with the handle request. Every time that we're handling a request, for example, in our Django, Flask, or any other web framework, we need to intercept it. And before we're handling the request, we need to create the span with the tracer and make sure whether we got a child of or a reference from the headers. Now we need to, once we created the span, we set some tags. Tags are our context. So for example, what URL is being called, what's the remote IP, what's the caller name, service, and so on. So this gives us a help what's actually going on. Once we cover the tracing part, we're looking to ship them somewhere. So in order to ship them somewhere, we need an ingestion system that will, according to our scale, if we're streaming 1 million traces, that might be fine. But if we're streaming billion of events and traces, That should be something that we need to maintain. Now, other than that, for the ingestion and the client, when we're thinking about, okay, we got all this data, what are we going to do with this client? So first of all, I would love to index the context and the tags. So I'll be able to filter them. Just as we saw before, I would like to see all calls that, been to a specific endpoint from a specific remote IP, because I know that I'm interested in troubleshooting that. And also, I would like to visualize traces. Once I'm finding out the right trace, I want to see that either in a timeline view that will tell me how long I spend time on each and every step, and also on a graph view. So it will tell me this is the story, this is the services that took part. Also, I would like to set alerts, because if something bad happens, obviously I want to get notified. And I can think of endless things like analytics and some big data about it, because that contains a lot of information that can be super useful. Just as an example, Jaeger brings out of the box a timeline view. So it takes care for the ingestion to some extent. I mean, you need to handle it, but it takes care for the ingestion. And it takes care also for the timeline view. So you can look at a call coming from your front end all the way to your back end. And, for example, Redis calls, you see exactly how long things takes in your system, which helps you really optimize the performance and understand latencies and understand errors in an easier way, because honestly, this is much easier to understand than logs. Few more things that worth mentioning about traces. So tagging traces is super crucial. We just find out, that we can add some context, but some great examples that you can add for tagging traces will be a good use in order to search, like if you're trying to pinpoint some problem in your application, but also for some aggregations. Let me give you some examples. Tagging traces can be used to tag identifiers. For example, like a user ID, device ID, I don't know, consumer ID, and things like that. This kind of IDs, when you're looking for a problem, when a customer comes and say, I had some problem with your application, you can easily search by a specific tag. Because think of it, traces are just like logs, but they're structured. And if you index them correctly, you can do much more meaningful things. So this is one thing. The other thing is flow control. So tell a tag that will tell me, what am I doing here? So for example, you might have a centralized a request processor that's handling different kind of requests or endpoints. So event type or request type and things like that can be helpful when you're doing aggregations. When you want to say, for example, for this specific service, how many events of type, I don't know, inserts am I handling, or any other kind of events out there. Also, business metrics. Remember that we talked about it on the metrical part. Business metrics can be great fit for tracing as well. So again, for aggregations, let's say I'm trying to understand how many items did this user buy, or how many items in general on average users buy on my application. This can be really helpful if I'm adding this kind of metrics. Think of it, traces are logs, but structured. Also, another thing that really helps with troubleshooting and even with search is to add the payload to the trace. I'm not talking about a specific field or a specific tag. I'm talking about the whole payload. Think of it. If for example, I'm going to add the all HTTP headers or body into the tag, I'm going to be able to to see and expose so many interesting information about, for example, user ID that is part of it, event type, payload information. All of these are coming within the payload itself, so it helps me to look at some more information. And once there is a problem, I can see exactly the information itself. This can be also, for example, key in a NoSQL database to understand exactly what is the item that I'm putting into the, for example, MongoDB, and exactly what's the key that I'm interacting with. And also, for example, the response payload from an HTTP call. If I'm getting a 500 error from third-party API, I'm super interested to know exactly what was in the payload, and not only the fact that it's been 500. And also, tracing can act as a glue. Once you're doing tracing correctly, trace can lead you to the right log. So instead of looking at logs, you can look at a trace, and given a trace, you would say, show me the logs of this specific trace, because this is the one that you're actually interested in. Also, you can say, I'm interested in a trace for a specific environment, or to go from an environment to a specific trace. Because if my trace is running as part of a Kubernetes cluster, I'm interested to know exactly what pod is it or what container, or the opposite way around. Like if I'm having some problems with some of the pods, I want to get into the traces that are part of this environment, specific environment. And again, both of these things can be achieved using tagging on top of traces. Now, just before finishing, I would love to elaborate on some more information about, best practices in observability and how to take it into your company, into your organization to leverage it. So, when I'm trying to think what would be the best solution out there for observability and tracing, I think we're talking about a solution that, first of all, is fully automated. You don't want to set up all this instrumentation and ingestion pipelines and correlations and building dashboards and alerts and so on. All of these things should come automatically. Also, you want to support as many environments because usually applications today are not composed with just a single environment. They can be run on Kubernetes, on cloud, on-prem, function as a service, and so on. And we need a solution that fits all. Also, we want something that connects all these distributed traces because that's the main problem that we're having. And we want to be able to search and analyze our data, just as we saw before, and something that helps me to pinpoint exactly the problem. The screenshot you can see over here is taken from Epsagon. This is a trace from end to end running on AWS using ECS, DynamoDB, Kafka queues, Lambda functions, HTTP APIs, and so on. And this is really, everybody can understand exactly what's going on here and what's the performance and whether we got some issues or not, because this is much easier. This is the thing that we should aim for. And in terms of, if you want to start your journey to observability and tracing, so first you need to identify your goals and our architecture model. Like, are you doing on-prem? Are you doing cloud? Where are you missing or issues or pain points that you need to address? And what would be your business goal in doing so? Is it a faster development iterations, easier troubleshooting time, reducing the MTTR, and so on? Second thing that you need to do is to understand what's your approach. Are you going to do it yourself or to pick a managed solution? Each one obviously have advantages and disadvantages. I think that in the era of today, do it yourself might have a bit more disadvantages because maintaining such a solution, unless you're at a really, really big scales, hundreds of billions of events every day, would just consume a lot of time from you to handle, and it might not worth the cost that you're saving. Also, try several solutions. Don't go with just a single solution. You can try one, do it yourself, open source, and another one managed. Just compare, be able to compare just as a good engineer is doing. Also, make sure that the service that you're picking integrates to your ecosystem. For example, that it will ship alerts to your PagerDuty or Ops Genie and Slack teams, and it supports all of your environments. And also evaluate the benefit and influence the decision makers. Especially, I couldn't say how much it's hard to promote a new tool within organization if the decision makers doesn't understand the benefit of it. So if you'll come prepared and show them that this is how it works and this is why it's good for us and this is the benefits that we're getting, usually decision makers will say yes. But if you're just coming, hey, we need 1, 2, 3, and give us some money for that, you're just not going to get it. So it's better to come with, once you're understanding the benefit, and then influence the decision makers. So just as a summary, and thank you all very much for listening, we understood that modern applications are not just like the old ones. They require a bit more than monitoring, or even a lot more than just monitoring, just metrics, just infrastructure. They introduce some different kind of problems and things to be aware of. And I think that if we're talking about observability, we understand that distributed tracing becomes like one of the most crucial components in such environments. Being able to do so really, can introduce much happier teams that, not focusing today on putting off fires, but, focusing on innovation. And also, I think this is a good recommendation for any startup or any medium-sized business. Stop implementing your own solutions unless it's really, really needed, because your company is probably not doing monitoring for a living. It's not doing tracing for a living. It's doing something else that the businesses need to do. So instead of building teams that build solutions for them, do what your business is doing and consider using existing solutions, because they'll provide probably a much better solution for you. Perfect. Thank you very much, everyone. I'm going to move on to the slide of the questions now. By the way, as I mentioned, I'm part of Heptagon. If you're interested, you can learn more. You can follow me on Twitter, and you can just ping me on email if you wish to learn more or to do anything else. I'm available there, and I would love to answer any questions also. So I'm going to move to the questions tab now. Okay, guys. Assuming there are no questions, it's been a pleasure to present it to you. I'm available in almost all medias that I've shared. And thank you very much, and stay safe. I really hope all these things will be passed behind us very soon. Thank you very much, and have a great weekend.